BCE Advanced Level Chemistry Practical Series, experiment number 29, tests for aniline. The aim of this practical is to identify aromatic primary amines by the reactions of diazonium salts. And we are going to be forming azo-dyes through diazonium salts. Now, let's go ahead and identify the reagents and the equipment we will be using for this practical. In this practical, we will be using aniline, also known as benzenamine or phenylamine. We will be using concentrated HCl acid, bromine water, sodium nitrite, phenol, sodium hydroxide. We will be using wash bottle containing distilled water, test tubes, a thermometer to measure the temperature, and some ice. We will be using ice bath in this experiment, so we will be using ice in a beaker to cool down our solutions. Now, let's move on to the first part of our practical. In the first part of our practical, we are going to see how aniline reacts with water, bromine water, and how it reacts with HCl. Now, let's take our aniline. We have aniline over here, and we are going to add a small amount of aniline into a test tube. We can see the color of aniline is going to be ranging from yellow to orange. So this is a yellowish orange color that we see. Now, let's add a small amount of water to see if it is soluble in water. If it is soluble in water, it will not form two layers. If we can see a layer separation, that means aniline is not soluble in water. As you can see, when a small amount of water is added, it is not forming a homogeneous solution. It is forming two layers, indicating that aniline is not soluble in water. Even if you mix it, we can see small droplets of aniline forms, and then they come together to form a single layer of aniline. Now, let's take another small portion of aniline into a different test tube. And to this, we'll add a small amount of water so that we can clearly see what happens when we add HCl. So we can see when small amount of water is there, we can very clearly see the layer separation. Now, let's add a small amount of HCl. So we have our concentrated HCl over here. Let's take our concentrated HCl solution, and we'll add a small amount of concentrated HCl to see what happens when we react HCl with aniline. As you can see, when we add HCl, little by little, the aniline starts to react. So, acid that we have over here, which is HCl, reacts with the base aniline and forms a salt. The salt that is formed is referred to as anilinium chloride. And as you can see, it dissolves well in concentrated HCl and forms a solution. When aniline is reacted with hydrochloric acid, we form a salt which is aniline chloride. And it is soluble in water. As you can see, there is no layer separation. That means when we react HCl with aniline, the salt that is formed is soluble in water. Let's see how aniline reacts with bromine water. We have our bromine water here. Let's take a small amount of bromine water into a test tube. The bromine water we have here, as you can see, is a yellow-brown color. Bromine is red-brown in color. So when it comes to bromine water, depending on the concentration, you will have either a very strong yellow-brown color or a bit of a pale yellow-brown color. However, this bromine water, if it shows a reaction with aniline, the color of the bromine water should disappear. Aniline, just like phenol, activates the benzene ring. So therefore, it readily shows the reaction with bromine water. Just like when it comes to phenol, aniline also forms a white color precipitate after reacting with our bromine water. So therefore, you will see the color of the bromine water disappearing as well as formation of a white color precipitate. Now, let's take aniline and add a few drops of aniline into this bromine water solution. As you can see, upon addition of just a single drop of aniline, we can very clearly see the formation of a white color precipitate. When bromine reacts with aniline, it forms 2,4,6-tribromoaniline, which is going to be a white color precipitate. And as you can observe here, the color of the bromine water disappears slowly. So if you mix it a little bit, you can see we do not observe the color of bromine water anymore. It is completely transparent. However, we have the white color precipitate forming, which is 2,4,6-tribromoaniline. So this is the observation when you react aniline with bromine water. Now, let's move on to the next part of our practical. In this part of our practical, we are going to use aniline and produce a benzene diazonium salt, and through this salt, we are going to form an azo dye. First, we are going to take aniline, we are going to take about 0.5 cubic centimeters of aniline. Now, we have taken about 0.5 cubic centimeters of aniline into a test tube. We can add 5 cubic centimeters of concentrated hydrochloric acid to this aniline. We have our concentrated hydrochloric acid here. Now, as you can see, we are adding concentrated HCl into an aniline sample that we have here. When we add concentrated HCl, it dissolves readily in concentrated HCl and forms a salt, aniline chloride. We have to add about 3 cubic centimeters of concentrated HCl. As you can see, we have completely dissolved the aniline that we had in the test tube. Now we have produced a salt, which is anilinium chloride, in this test tube. So now we'll allow this sample to cool down. It has to cool down below 5 degrees Celsius. So we are using an ice bath to cool down the sample below 5 degrees Celsius. After dissolving aniline in concentrated hydrochloric acid, we are now going to take sodium nitrite and dissolve it in water. We have our sodium nitrite over here. We'll take a small sample of sodium nitrite. We'll transfer it to a test tube. And now we'll dissolve it in water. If 2 milliliters of water isn't enough to dissolve it, we can add a little bit more water. And after completely dissolving sodium nitrite, we can place it in the ice bath to cool this solution also below 5 degrees Celsius. Now we have two test tubes here, one containing aniline and hydrochloric acid, the other one we have our sodium nitrite solution. Now, after preparing our sodium nitrite solution, we are going to prepare our phenol solution. We have our phenol sample here. We are going to take a small amount of phenol and we are going to add 10% sodium hydroxide to it. Let's take a dropper and take about 0.5 milliliters of phenol. And to that, we are going to add 10% sodium hydroxide. We will be adding around 5 milliliters of 10% sodium hydroxide. Now, as you can see, when we have added around 5 milliliters of sodium hydroxide, we can see all of the phenol dissolved in the sodium hydroxide and formed a solution. Phenol is acidic in nature, and when you react sodium hydroxide with phenol, we produce sodium phenoxide salt, which is soluble in water. So what we have here is sodium phenoxide. Now we will allow that sample also to reach temperatures below 5 degrees of Celsius by placing it in a water bath. Now we will allow it to cool down for a while. While the samples in our test tubes cool down, let's talk about the reaction that is taking place over here. So we have aniline dissolved in hydrochloric acid, and to that sample we are going to add sodium nitrite. Sodium nitrite in the presence of aniline and HCl will produce benzene diazonium chloride. This is also referred to as an aromatic benzene diazonium salt. Benzene diazonium chloride or aromatic diazonium chlorides are more stable than aliphatic diazonium chlorides. However, if the temperature is not kept between 0 and 5 degrees, at higher temperatures, this benzene diazonium chloride will turn into phenol, nitrogen, and hydrochloric acid. So you can figure out if you have done the reaction at a higher temperature and if we have produced benzene diazonium chloride or if we have produced phenol by a few observations. If we have produced phenol instead of benzene diazonium chloride, you will see the formation of nitrogen gas bubbles, or your observation would be the formation of gas bubbles. And when we have produced benzene diazonium chloride, the solution that is produced is going to look a pale yellow color. So after producing benzene diazonium chloride, while keeping this solution between 0 to 5 degrees Celsius, we are going to react it with alkaline phenol solution. So in the alkaline medium, we are going to see benzene diazonium chloride react with phenol to produce an azo dye, which is going to be orange in color or red in color. So color may range between orange and red. So now let's observe if the solutions have reached the required temperature, we can start mixing sodium nitrite with aniline solution that is reacted with HCl. Now we can use our thermometer and we can observe the temperature of our aniline and HCl solution. We can see the temperature is going down. And at present, the temperature is between 0 to 5 degrees Celsius. It is around 3.5 degrees Celsius. Now that we know the temperature is between 0 and 5 degrees Celsius, let's take our sodium nitrite and aniline mixed with hydrochloric acid and let's mix them together. We have to keep stirring them while you mix it. And we have to make sure that we keep the temperature between 0 and 5 degrees Celsius as well. So we have to make sure that these test tubes remain in the ice bath for the most part of this experiment. So while keeping it in the ice bath, we can add our sodium nitrite. And as you can see, we are forming a yellow color solution. This yellow color solution is our benzene diazonium chloride solution. Students, now we have made benzene diazonium chloride. So we have an aromatic benzene diazonium salt, which is benzene diazonium chloride that is formed here. And you can see it is yellow in color. And we have to make sure that we keep it in the ice bath as much as possible because this is stable under low temperatures. At high temperatures, this will turn into phenol, nitrogen, and HCl. So we'll take a portion of our benzene diazonium chloride into another test tube. And to this, let's add our alkaline phenol solution. We have our phenol mixed with 10% sodium hydroxide solution over here. Now we are going to add phenol mixed with 10% sodium hydroxide into our benzene diazonium chloride salt. Now you can see as soon as we added it, we saw the formation of a red color dye. So this red color precipitate that is formed is our azo dye. This is our azo dye. We keep it here. We'll allow it to cool down for a while and we'll observe it again after a while. Students, now we have allowed the mixture to react properly at lower temperatures, and we can see the color of the dye that we have formed. And you can see what we have formed is a precipitate. You can see by observing the walls of this test tube, the precipitate that is formed is a red-orange color. So this is more towards red than orange. So what we have formed here is p-hydroxyazobenzene, which is azo dye. So we formed this azo dye through benzene diazonium ion. Now this is a test that we can use to identify aniline. In summary, let's take a look at what reaction we looked at today. Initially, the first part of this practical, we took aniline and we dissolved it in water. And upon addition of water, we realized aniline forms two layers with water, indicating that it is not soluble in water. Then we moved on to adding concentrated hydrochloric acid to aniline. Aniline is a base and therefore it reacts with the concentrated hydrochloric acid, forming anilinium chloride, which is going to be a water-soluble salt. So upon addition of HCl, we saw that aniline dissolved in HCl. Now, afterwards, we added bromine water to aniline. Upon addition of bromine water, the color of bromine water, in our case, the color was pale yellow-brown color, and when we added aniline to it, we saw the color of bromine water disappeared while forming a white color precipitate, which was 2,4,6-tribromoaniline. Afterwards, we moved on to forming our azo dye. In the first step of forming the azo dye, we had to form our benzene diazonium ion. Benzene diazonium salts are usually unstable. At room temperature, if you carry out this reaction, benzene diazonium salt will not be formed. However, when you mix aniline in the presence of HCl and sodium nitrite, if we carry out this reaction at lower temperatures, we saw that we are forming benzene diazonium chloride, which is our diazonium ion. And while maintaining lower temperatures to this benzene diazonium chloride, we added alkaline phenol or phenol in an alkaline medium. When we added phenol in alkaline medium into our benzene diazonium ion solution, it formed an orange-red color precipitate, which was our azo dye. So this is how we identified the presence of aniline. Now, let's move on to other theory parts revolving around this practical and some questions that is revolving around this aniline practical.